Hi everyone, welcome to the fifth lecture in the series of Business Analytics course. In this video, I will be covering a week 4, which is basically dealing with the basics of our economics, which is demand response curve, how demand changes with respect to price, and why we want to model it, right? Then the next part in this week would be simple linear regression. This is one of the techniques which we use to model the demand response curve. So yeah, let's get started. I hope my screen is visible. So we will start with the demand response curve. A few basic things before we get into demand response curve. What do we mean by this? What is demand? What is response? So let's say there is some good, G double D good, and it will obviously have some price associated with it, right? So we want to know how this uh, demand of good, basically how many things which you are going to purchase, right? So demand is nothing but number of goods we purchase. So how many goods we are going to purchase when there is some price. And even if you have not studied economics, but I assume you have studied some microeconomics in your business data management course, right? Which is a prerequisite for this course. We have a theory that as price increases, demand should decrease. It's very obvious. And this is for the normal goods, right? What are normal goods? So first, let's know this thing. Because in general, whatever we would be studying is going to be for normal goods. Normal goods are basically when your income increases, demand also increases. This is very important. Then there are few things also known as inferior goods. Why? So when our income increases, their demand decreases. So you need to think of it like that way. In general, let's say you are a normal human being and you have some liking for ice creams and all. So let's say you have some fixed income. At that point, you can afford something. If your uh, let's say probably 4 ice creams in a month, right? But when our income increases, maybe we have more purchasing power. Now we can afford 2 ice creams per week. So that is one thing which we should know. These are normal goods. When our income increase, we want to purchase them more. And what is inferior good? Let's say I cannot have access to ice cream, then I go for some lemonade. So that is inferior considerate because if I get more money, I can go ahead and purchase the other good. So inferior good is something which, when our income increases, we stop, taking that. And this law of demand, which we studied, this thing is formally known as law of demand. And what does it state? For normal good, remember we were talking with respect to income here. Income is what we have. And law of demand is in between price and the quantity demanded. So know the difference. Both are rupees. Income and your price are both, currency in terms of currency, but both are physically different. Income is what we have and what we can use. Price is something which we have to pay. So law of demand says for normal goods, price of good is inversely proportional to quantity demanded. Okay. So this is something which we should know that when we are going for a normal good, basically if our income will increase, we would also purchase it more. So for such goods, if the price would increase, our demand would decrease. And there are certain reasons for this. Law of marginal utility, if you have studied, law of marginal utility states, the more you consume something, your utility from that product decreases. In short term, let's say you like pizza a lot. The first pizza you will eat will give you more satisfaction. Second pizza, a little less. Third pizza, okay. Fourth pizza, your tummy is full. And if you keep on eating more, then it will cause problem to you, right? So this is what law of marginal utility states. That when we keep on increasing consumption of some good, our satisfaction, which is utility, keeps on decreasing after certain point. And that this is one of the reasons why you know the price is going to be inversely proportional to the quantity demanded. Now let's have a look at the figure, how it looks like. So we will have this kind of graph where we have quantity, which is represented by Q, and here we will have price. Okay, and our graph would look something like this, right? What does it mean? Let's say this is some specific point P star, and corresponding to it, we have Q star. This is price at equilibrium. We will get into it. What is equilibrium? Now let's take this is price P1, and this is the corresponding Q1. Similarly, let's take another price, which is P2. We will have corresponding quantity Q2. So as you can see, when my price increased, right, this is increased. When my price increased from P1 to P2, my quantity decreased from Q1 to Q2, right? So this is something which we need to understand, that as we will keep on increasing our price, right? Because let's say, imagine you are a company, you are making some products, right? You would try to get more money for that product. If you are pricing, let's say, a chocolate for 5 rupees and 10 people are purchasing it, you will be getting 5 into 10, 50 rupees, right? So therefore you would try to increase the price, right? If I increase my price from 50 rupees to 5 rupees to 6 rupees, my revenue, the amount of money which I get from them, increases from 50 to 60, right? It should ideally increase. But the issue is, the moment I increase my price of chocolate from 5 to 6, 10 people will not be purchasing it. There would be some drop in my sales. Maybe 9 people are purchasing it. So therefore, this is very important to model how our quantity is going to change with respect to price, because we are going to maximize our revenue or profit. So these are two terms which you should know, and we will be discussing them further. But that is one reason why we want to model this curve. At least we get some information how quantity changes with respect to price, right? Because price is something we can control, right? If we have access to, a monopolistic market, we know every person is going to come to us only, then we can control the price. And then we know how demand will change with respect to these things. So this part which you are seeing, this part is called as latent demand. And this part, basically the part which you are seeing after P2, is called as consumer surplus. Okay. Now let's understand what is this latent demand, what is this consumer surplus, and this thing is known as demand response curve. In short, you can say DR curve. So there are few properties of demand response curve which we should know. And these are quite obvious. We do not need to, think something out of the box. These are quite obvious properties which it should follow. First one is going to be this demand response curve. You will see it being non-negative. It cannot be negative. In general, it's very obvious that sales is not going to be negative, right? Else, it's also going to be continuous and differentiable. And as I said, because of law of demand, when price is going to increase, demand is going to decrease. Therefore, it will in general have a downward slopes. So let me write these properties. First one is continuous. Then we have differential. And then we have non-negative. And the fourth one is it should be a continuous, differentiable, non-negative, and it has to be downward sloping. So this is most important, downward sloping. differentiable. Okay, so these are the four properties which we should know. Now, what is latent demand? These are just few different concepts of microeconomics to know why we are studying these things, why we want to model the our curve and all. So when we come to latent demand is nothing but latent word itself means hidden, right? You would have heard this term latent heat in physics a lot. So basically that means hidden. So latent demand is basically a hidden demand, or you can say a demand which has not actualized. And why is it so? Maybe people cannot afford that thing. So when I say this is my latent demand, or you can say hidden demand, demand not satisfied. So if you see here, at this point, let's say if you can only afford to pay something less than P1, right? So you are falling in this region above this red line, right? This shaded region. So you don't have money to purchase this good because the price to purchase it even rupees, right? We can take an example. Let's say we are going for some food. Pizza cost 100 rupees, but we only have 60 rupees. So we have some demand in ourselves, right? It's a hidden thing, but we cannot purchase it. That is why it is latent demand, right? Because it is something which is not met. Now we need to understand how this latent demand changes with respect to price. So if you realize, if we keep on increasing price, right? If my pizza price, which was 100 rupees, if it increases to, let's say, 120 or 150, then whosoever was having even 90 rupees or let's say 110, he will even not even able to purchase that. So therefore, when we increase the price, our latent demand increases. So this is very important thing. Latent demand increases with respect to price. Okay. And another one is consumer surplus. So surplus is basically, the word surplus means something extra. So when you read this thing, consumer surplus, it says basically something extra to the customer. So what it means is the extra utility, or you can say the extra fulfillment which a customer achieves after enjoying a service at lesser price, which they can afford. Let's say you have 150 rupees and you wanted to purchase a pizza for 150 rupees, but they are going on a sale, right? So we can purchase the same pizza to eat at 100 rupees. And that is going to give us a fulfillment. Yes, we ate pizza and we also saved 50 rupees. So that fulfillment is basically captured in the consumer surplus, right? So this is going to be uh, extra utility enjoyed by consumer, or you can say customer, because price is less than what they can afford, or you can say willingness to pay what they can afford, willingness to pay, right? So when you are willing to pay 150 rupees, but you get the same good for, let's say, 100 rupees, that is going to be known as consumer surplus, because we got that extra satisfaction for 50 rupees. So this is something known as consumer surplus. Now we would see what is elasticity, right? Because we see this thing, right? My price is changing, demand is changing. So we need to capture this change in some metric, some quantifiable metric, and that quantifiable metric is elasticity. So that is very important, and you will see for sure some questions on elasticity. So please, please, please pay attention to this concept. What is elasticity? Percentage change in demand divided by percentage change in price. Okay. So the symbol which we use for demand is going to be Q or D, both are fine. So this will become So I hope you understand this notation. The first thing says percentage change. Percentage means we are taking uh, difference. That means it is going to be change in my quantity demanded divided by my initial quantity. Similarly, this delta P says change in my price upon initial price, and 100 would be cancelled because we are taking percentage. So you can also say it is going to be fractional change in demand divided by fractional change in price. Okay, both are fine. One thing which we can see, we have elasticity. The symbol elasticity is equals to delta Q by Q. I am replacing a D with Q. This divider becomes P by delta P, right? And if you will see, this looks like delta Q by delta P into P by Q, right? So this is what we have elasticity looks like. And you can again write it like Q final minus Q initial upon P final minus P initial into P initial divided by Q initial. So this is very important. What is my elasticity, right? Q final minus Q initial divided by Q initial. And then we have a whole thing divided by P final minus P initial divided by P initial. So this is what you have here. And after this, if you see, if we take this limit, delta P tends to 0. Basically, I'm saying my price is changing very little. So this thing would be changing into derivative, and your elasticity would become dq by dp p by q, right? And if we change this thing, again, you can do some transformation, it will change. But the thing to notice was this thing, delta q by q whole divided by delta p by p, this thing is known as, you know, elasticity between 2 points, right? I have 2 points. One is initial, one is final. That is why it is elasticity between 2 points, right? And when I ask you what is elasticity at certain point, right? At certain point, this is elasticity between 2 points. When I want elasticity at certain point, basically that means we are talking about this case, limit p tends to 0. Okay, so that is one thing which you should know. And yeah, so there is one thing which we should know, another apart from these ones, is that we have linear demand response curve. We also have non-linear, or you can say constant elasticity curve, which we will be studying later. But at first, we start with the linear demand response curve. What does linear demand response curve? It says my demand, which is going to be function of price, is going to be a linear function of price. What does that mean? It would going to look like something like A plus BP. And in general, you will see the common notation used throughout the course is D naught minus MP, right? Why this minus MP? Because this thing minus means my demand is changing negatively with respect to price, right? My demand is changing. If my price is increasing, demand is going to decrease. So if you again want to calculate elasticity, we remember elasticity is nothing but dq by dp, and then we will have p by q. So if you take derivative of this thing with respect to p, you will end up having d naught gives you 0 minus m, right? So this gives you minus m, and you have p in the numerator, q at that point, right? We will be calculating this thing at certain point, right? At some price is equals to, let's say, p. So p, we will end up having minus mp, and in the denominator you will have d naught minus mp. So this is our elasticity at certain point in the linear demand curve. And how does linear demand curve look like? quite obvious. We have P here, we have demand here. You can use D or Q, whatever notation you use. It is going to look something like this, right? And this D naught which you are seeing, this is going to be demand at price equals to 0. So you can say this thing which you see here, this intercept is known as D naught, and the name given to it is called as market size. Basically, how much market you can capture by giving you goods for free, right? That is why it is called market size. If I start giving my good, which I am making for free to everyone, then I will have most people joining me in purchasing that good. So therefore, this intercept which you are seeing is known as uh, the market size, because at this when price is 0 at this point, I can capture maximum people, and this is something I can capture at max, right? Because I cannot pay people to take goods, right? I cannot pay people to take my goods. So therefore, my demand at max can be this, which is known as market size. And you will see some questions which ask what is market size, what is other things. Similarly, if you see this point, let me extend this one further. If we extend it further here, and this will come down somewhere here, this point where my demand becomes 0, this price is called as satiating price. Satiating price. Okay. So I hope this notation is quite clear to you. What is satiating price and what is going to be my market size and how we capture it. We have covered elasticity. We have also covered this thing. So that's one part. And now, as we were discussing elasticity, let's come to one more thing. If my elasticity turns out to be greater than 1, there are two cases. Elasticity is equal to 1, and then we have elasticity less than 1. So this thing is known as unit elastic, or you can say delta Q by Q is equals to delta P by P. That means if I am changing if my percentage change in price is going to be 10, then my percentage change in supply is also going to be 10%, right? So this is one thing we can infer from here, because if you put in the same values, basically this thing, delta Q O Q by Q divided by delta P by T, here you will come to know this thing is my percentage change in quantity, this thing is my percentage change in price. So when elasticity is 1, percentage change in price is same as percentage change in your quantity. Then we have this situation which is called as elasticity is less than 1, so it is going to be inelastic, right? It is known as inelastic. What does it tell me about the good? It tells me that my delta Q by Q is less than delta P by P. Or I can say my percentage change in demand is less than percentage change in price. So you know this thing, if I increase price by 20%, my percentage change in demand is going to be less than 20%, right? If you know the fact this good is inelastic. A very good example would be salt, right? You generally, everyone is going to purchase salt, or let's say medicine, right? If you have some issue in your health and you are supposed to purchase a medicine, then in case of it becomes inelastic. Why? Because regardless of the price of that medicine, you would be purchasing medicine. So therefore, we have to consider this situation that whenever a good is inelastic, it's much beneficial for the producer that they can increase the price, because they know uh, if I increase price by 20%, maybe my percentage change in demand would be 10%, right? It would fall down by 10%. If I increase by 20%, it would be surely falling down, but something less than 20%, right? And the opposite is case for our E greater than 1. This is known as elastic. What does this tell me? That my percentage change in quantity is going to be greater than percentage change in price. So delta Q by Q is going to be greater than delta P by P. This tells me that my consumer base or customer base is very sensitive, or you can say sensitive to price. That means if I change price by a little bit, my demand will fall down a lot. So this is a very difficult situation to manage. And as a producer, if you are producing something, you would not like this, right? Because uh, if I change price by let's say 10%, probably my demand will fall by 20%. So this is something not beneficial for the producer. And this is something we can know. And how do we capture the demand? So, if you want to increase your revenue is basically how much you are selling and how much price you are charging. So basically demand into my price. But demand itself is a function of price. So we need to make sure the product of these two things it as its maximum. If my price will increase, demand will decrease. If my price decreases, demand increases. So the product in general needs some good combination. And when I was making this diagram, this one, you see here, I refer to this P star and Q star. So this P star and Q star are that only. This P star is my price at which my demand, or you can say at which demand into price, or you can say revenue is going to be maximum. Similarly, we can do the same thing for our profit. So this is what we have for this situation. Now, one thing, when we know elasticity is going to be less than 1, we can simply increase price to increase revenue, right? If you are the person who is making some medicines and all, and people will purchase that, it is very essential to them, right? Therefore, elasticity is going to be less than 1. And you can regulate that price, you will increase it. If you, let's say, increase it by 20%, your drop in demand would be for sure less than 20%. Why? Because elasticity is less than 1, or you can say my delta Q by Q is less than delta P by P. So if I increase my price, percentage increase in price is 20%, then for sure percentage decrease in quantity is going to be less than 20%. So therefore, in this situation, when elasticity is less than 1, I can simply increase my price to capture, increase my revenue. And whenever I have elasticity greater than 1, right? When I have an elastic product, I can increase my revenue only by, this situation. When my elasticity is greater than 1, revenue increases by decreasing price, or you can say closer to 0. Right? Let's say if I know I am making something and people are very sensitive to the price, right? I know if I have been selling some good for 10 rupees and if I increase price to 12 rupees, suddenly my customer base drops from 10 to 3. That's a very big change, right? I increased price by a little bit from 10 to 12, but my customer base fell from 10 to 2. So that's a very big change. Therefore, my product is going to be elastic. My elasticity is greater than 1. And in this case, if I want to increase my revenue, just in case, revenue is basically my demand into price. So if I want to increase my revenue, I need to set my price closer to the 0 side. Not 0, because if I make it 0, then revenue is 0. But I need it to make as small as possible, right? Uh, then this quantity is not 0 because my price has been decreasing a lot. My demand would be increasing a lot. And in that case, I can capture maximum revenue. So know this thing, when your elasticity is less than 1, your revenue needs to be increased. So we will just simply increase our price, because we know if I increase my price, customer base falls very slowly. But in case of elasticity greater than 1, we cannot do the same. If we increase price by a little, customer base falls by a lot. So, if I increase my P a little, my D, which is function of P, it will fall by a lot. So in case, because I want to increase my revenue, this is a product of these two. So in case of greater than 1, I need to make my P as close to 0 possible. And in case of elasticity less than 1, I will simply increase my P. That's my strategy. And now, how do we model this thing? So if you have seen, I told we have linear demand response curve. which says demand is a function of price and it is looking like D naught minus MP. So how do we do such thing? As I told you, D naught, few important things again mathematically. D naught is basically my D at P equals to 0, right? If I put P equals to 0, this becomes 0 and I get D naught. And we call it as market size. Then we have P satiety. What is this P satiety? Demand at P equals to P satiating is going to be 0. Or I can say demand at which, price at which demand is 0. And what is the formula for this thing? So it's quite obvious to see that we want our demand to be 0. So this thing should be equal to 0 in this case. And that simply means we have P satiating is equals to D naught by M, right? And now we need to understand what is our elasticity. So elasticity, because in this throughout this course, we would be dealing with only demand elasticity, or you can say we know for a sure normal goods are there. So if we increase the price, demand would decrease. We know this thing for a sure. So therefore, we are only interested in the magnitude, not the sign. So here, if you see in this derivation, right, you see this minus, we are only interested in the magnitude. Because I know if I increasing the price, my demand should fall down. So if I know the magnitude, if I increase price by 10%, my demand will fall by 2 times. So that means my elasticity is 2, right? So that is how we do. We know this nature by default. If my demand is increasing, price needs to fall down. If my price is increasing, demand needs to fall down. So therefore, we only need magnitude. So we can ignore this thing, or you can say elasticity is going to be magnitude of delta Q by Q divided by delta P by T. And in this case, as we found out, this thing is going to be this one minus MP by D naught minus MP. When we take the mod, or you can say we are only considering magnitude, this becomes M P upon D naught minus MP. Again, giving you disclaimer, this is only the magnitude. So whenever you will be solving the question, know this thing. If my elasticity is 2, it means if I change price by 10%, my change in demand would be 20%, right? Because delta Q by Q is divided by delta P. So if this thing is 10, this thing is 2, this needs to be 20%. So this is how you solve. And this 20% is obviously going to be in opposite direction. If I'm increasing my price, then this should be decreasing. If I'm decreasing my price by 10%, my quantity, percentage change in quantity increases by 20%. So know this thing. And yeah. One more thing which we should know, that elasticity keeps changing here. Elasticity is not constant. So know this thing. In linear demand response curve, elasticity is not constant. As you can see here as well, elasticity itself is a function of price, right? We have elasticity is equals to MP divided by D naught minus MP. So therefore, elasticity itself is a function of price and it changes with respect to price. Now let's see what is going to be my elasticity at price equals to 0. If I put price equals to 0, it becomes D naught and this again becomes 0. So basically 0 by D naught, which is same as 0. What if my put elasticity at price equals to P satiating? What was my P satiating? MP divided by D naught minus M. P satiating, if you remember, is D naught by M. So we will have D naught by M. So this becomes MP divided by 0. And you can say this tends to infinity. So therefore, my elasticity changes from 0 to infinity as we keep increasing price from 0 to P satiating, or you can say satiating price. My elasticity changes from 0 to infinity from when we change price at 0 to P satiating. So remember this thing. This is very important. And as I said, this was one big disclaimer that we are only considering the case where elasticity is only needing the magnitude. In this case, throughout, you will just take the mod for this ratio here or maybe somewhere else. If you have already taken machine learning foundation course, you would be already familiar with the word regression, right? Regression word tells us about, it's a type of machine learning technique which we use to predict something. And most of the time, it has to be continuous variable. So whenever you want to do any type of prediction where we are dealing with continuous variable, then we use a regression. So that is why this is called as simple linear regression because we are going to predict something, linear because we are going to use linear combinations, and the equation which you will be getting, it's going to be linear with respect to the parameters. So that is one important thing. And simple because at this point in this week 4, we will be only considering one variable input. So let's get started. So what is a simple linear regression? The basic idea is I have some input variable which is going to be x, and then I have some output variable which is going to be y. How do I model some relationship between them given I know that they tend to follow some kind of linear trend, right? So if you see this thing, if x is on my x-axis, y is on my y-axis, I can directly see from here that my, there is a sort of linear trend in between my xy variables. So in the scenario where we are sure that there is one sort of a linear trend between xy axis and the variables, then we use linear regression to capture this linear relationship. So the equation looks something like this. Y is equals to beta naught plus beta 1 x1. Here, because we only have one variable, we are restricting ourselves to x1. You can obviously name it something else, x, without any subscript, because in case of simple linear regression, x generally means only one variable. But we can extend this idea of simple linear regression to multiple linear regression, where we would also have x1, x2, different variables. So before we get started into these things, I just wanted to cover some terminologies related to linear regression. So here you will see the variable y and variable x. So there are few common names which are used for variable y and variable x. So a lot of time you will see y being called dependent and x being independent. So one is dependent and this one is called as independent variable. Again, it depends a lot on which field of study you are coming from. So maybe if you're from neuroscience, there is some other terminology. Maybe if you're from econometrics, you will see, other way. If you're coming from statistics, there are other words which we use. So terminology can change from, field of study to field of study, but the my idea remains same. So one is dependent, independent. Then we have, uh, explained, and this is explanatory. Then we will have, independent, dependent, explained, explanatory, predictor, predicted. So this is one thing else, predicted, because y is something which gets predicted, and then we have predictor. We use x to predict y. Then we also have regressor. So this x is called as regressor, and this y is going to be called as regressand. So these are few different names which you will see being used here and there. But in general, this idea of explanatory variable and the variable being explained remains constant. So whenever you hear a word independent or let's say input variable or regressor, then you should know we are referring to the input side. And whenever we use any of these four words, dependent, explained, predicted, regressand, or let's say output, so you must be able to figure out what we are talking about. So as I said, we have two parts of this equation. So the idea is when I know, uh, right, there is some kind of linear relationship between my input variable and output variable, or you can say explanatory variable and the variable being explained. So in that case, I can definitely go ahead and write this thing, right? So we have y is equals to beta naught plus beta 1 x. At this point, I'm only considering the x as the only input variable, so that's okay. Now we need to realize what is this telling us. If you remember, probably you would have studied this equation, y is equals to mx plus c in your 10th class, or probably even in 6th class it's taught. So what does this equation tell us? This tells us that y and x is basically a point which lies on a line. And this thing is basically equation of a line, right? Y is equals to mx plus c is the equation of line. So if you try to match this equation in yellow with the equation in blue, you will see this thing that we have a similar thing. So the idea is when we write this equation, right, uh, we have some data which we know follows some sort of linear trend, something like this. Not exactly everything is on the line, but we know there is some sort of linear trend. So then we can at least capture this trend, right? Maybe we cannot capture exact points, but we can capture the trend. So the point of regression is we can capture the main trend. And this is what happens. So basically, the actual equation is y is equals to beta naught plus beta 1 x, and then some white noise, or you can say, this is going to be error. And what is this error? This error belongs to normal, 0, and then some variance. So this is a important thing which we should know, that the error which we have is normally distributed. It's not about the variable. I'm not saying my x should be normally distributed or y should be normally distributed. We are saying this residual part is something which we cannot model. So when we have this kind of data, something which roughly follows a linear trend, we know that we can, capture this red line. I cannot capture exactly how I can predict this blue point when I'm at this x. I can not predict this blue point when I'm at this x, but at least I can get some proxy, some kind of rough estimate. So this linear regression helps us in capturing that rough estimate. And that is why it is very important to study about this. In the description, I would actually give one video which you all can watch before your quiz one. Uh, in that video, I have taken, the Excel output from the data analysis toolpack, and then we dissected each and every part. Your standard error, variance, your ANOVA, chi-square, your t-test in the bit bottom. So these 4 5 things are more better if we cover after studying multiple linear regression, but you should know few basic things from there. So one of the basic things is this one, that our error is always normally distributed. This is something which you should know. And after that, as I said, this linear regression helps us in capturing this general trend. We don't get we cannot exactly predict everything. We only capture the general trend. So this is one thing which we should know. And there are few assumptions when we go ahead with the simple linear regression model. So these are few things, maybe if you know, it can help you in the MCQ type questions. So the first assumption is that errors are going to be independent. If I'm at, let's say, some x value, x is equals to 0, then the error, right, this epsilon part which you are seeing, this has nothing to do with the error which I would be making when x is equals to some other value. So this is one thing we should know, that errors are going to be independent. Variances is also going to be equal. So all errors have equal variance. What do I mean by this? It means I cannot have very high variance for some values of x and very less variance for some values of y. So this is one thing. And the last one which we should know is errors are normally distributed. Again, if you check in any standard econometrics books, there are, I think, 6 assumptions: heteroscedasticity, equal variances, errors are normally distributed. Then we also have autocorrelation. So there should be no autocorrelation. Basically, if I'm at, let's say, x for some row, the next row should not have any kind of relationship with that. So this is one part which we should know. And yeah, so using this, actually, we can do a lot of stuff. And with this, basically, we try to model these things. So if you remember, demand was a function of price, right? So we had this equation, right? So you can imagine if I have, let's say, access to lot of price values. So if I have, let's say, price, and then I see demand, let's say 1, 2, 3, 4, 5, and demand goes like 10, 8, 6, or 2. So now you can see this pattern, right? When my price was increasing, demand was decreasing. Now here you can see there is everything is on a straight line. This is just for an example, but very much possible I can change this 6 to, let's say, 7, and this 2 to, let's say, 3. So now I see all the points are not on a straight line, but still I can see there is some sort of rough trend, right? My demand is decreasing when price is increasing. So this sort of trend is there, although not exactly. So now I can use my linear regression to capture that trend. And capturing the trend is very important, right? Because if we have captured the trend, then we know what if I further increase my price from 5 to, let's say, 7, what will be my demand? So then I can predict my demand using this relationship. And that is why it is very important to know how to model this thing. So that was one thing which we should know. After this, there is one more thing which we should know, that is going to be non-linear demand response curve. What is this? As the name suggests, in this one, we were having a linear demand response curve. What if our response and the uh, other stuff is not going to be a linear, right? So in this situation, we know this thing that demand and response are always and always inversely proportional. So if I have demand and there is my price, so I know this thing that they have to be inversely proportional. One way was I have this sort of demand, right? This gives me a linear demand response curve. And here we were having elasticity, which was also a function of price. But I can also have this kind of situation, right? This is also inversely proportional. As my price increases, demands keep on decreasing. But it's not a straight line, it's a curve. So in this kind of situation, the biggest thing we should know is that elasticity is constant. And after this, what is going to be our equation? So when we model this kind of curve, we have this kind of equation. D, basically demand as a function of price, is going to be some constant C, and then e to the power minus epsilon, right? So now this epsilon, it's better maybe we can write as elasticity. This is important. So this equation which you are seeing is called as non-linear demand response curve equation. And here this epsilon is my elasticity. Now this is very important to know that in this graph, my elasticity is constant. Therefore, I can take this and this E is not going to change. So let's say this point is, P1, D1, this point is P2, T2. I can very easily write that T2 is going to be C, P1, sorry, 1 to the power negative epsilon, and then similarly, D2 is equals to C, P2 to the power negative epsilon. And now when I have this relationship, it's very easy to divide those two things. I end up having d1 by d2 is equals to p1 by p2 whole to the power negative epsilon. And when we take the logs, we end up having epsilon is equals to log. We can have opposite things. So you can stay with that d1 by d2. And in the denominator, as I was saying, we will have opposite. So either you write negative, and if we take negative inside, we take the log. Maybe I can just do it stepwise, you know, log d1 by d2 is equals to negative epsilon or elasticity log p1 by p2, right? So this is what we have, and then elasticity becomes negative log d1 by d2, this whole thing divided by log p1 by p2. And we can do one more thing, minus, we can make it to plus log d1 by d2 divided by log p2 by p1. So I took that minus inside and then I just flipped the signs. So this is one thing which we can do. And we should be very cautious of this, because this, whenever you hear the word, elasticity is constant. Whenever you see any question which says elasticity is always constant, we use this equation. Whenever we see the word non-linear demand response curve, we have to use this equation, that demand is going to be C into price to the power of elasticity, and this is going to be the formula. So remember, you just take any two pairs and then you can use the any two pair values, and then we can go ahead with this one. Now, this is something we should see here, that this demand response curve which we have written, this is non-linear. And what if I want to, go ahead and do some estimation? What would be my price at certain point? What is going to be my demand at certain point, right? So this is a non-linear curve. Until unless I know elasticity, right? I need to know two things, elasticity as well as my C, to estimate some demand when I know elasticity is constant. So if we don't have access to C and elasticity, then we cannot do that. So the problem setting is going to be something like, I have access to the previous historical records where I can see my price and my demand. So let me write it. Historical records gives us price and then the demand, right? So we will have access to these two things. But we know these are going to follow this thing, right? A constant elasticity demand response curve where we don't know the elasticity and that constant C. So how do we estimate that, right? We have not seen this kind of setup where we can estimate this, but we know this kind of setup, right? Whenever I see my data set follows some kind of linear trend, then I can capture that linear trend using the linear regression. So somehow, if I can convert this equation, demand as a function of price is equals to C into P to the power minus epsilon into some linear equation, then that would be much easier. So we will basically apply log transform, right? And this equation, demand as a function of price is equals to C times P to the power minus epsilon, will change to ln of D is equals to ln of C minus epsilon ln P, right? So now we have two things separately, right? This was our intention, this thing and this thing, right? And if you do comparison, what do I end up having? My LNC is going to be my intercept, right? This one, beta 0, this one, beta 0, and my minus epsilon is going to be this beta 1. So whenever I draw my linear regression line after the log transformation, I can get access to both. C, LNC, I will have basically intercept is going to ln C, or C is equals to e to the power intercept, right? And then we know slope, which is here, beta 1, which is same as minus epsilon. So we can say elasticity is going to be negative of my slope, right? So this is how we convert our constant elasticity demand response curve into something which we can estimate. Why? Because we have access to linear regression. We know if there is some sort of linear trend, then I can capture that using the linear regression. But when we come into the domain of constant elasticity, we now do not have access to the same privilege. I cannot estimate my elasticity and this constant C when I am in this kind of setup. I know if it was linear, I could have captured the trend, but it is not linear. So when we apply log-log transformation, you can very much see that this non-linear relationship converts into a linear relationship. And therefore, then after the conversion, I can basically get access to these three things, right? My log C and then this epsilon, which is my elasticity. And that's just the comparison. So after my linear regression, I get, beta naught and beta 1. So I know this thing, my intercept, which is beta naught. So if I take e to the power intercept, I will get access to my C. And when I take this slope, this negative of slope is going to give me elasticity. So I hope you got the basic idea why we study linear regression, because whenever we have to capture some linear trend, we need to deploy this method to capture that. So please be very much aware of the terminology. Most of the time you would be seeing explanatory and explained variable, predictor and predicted. So these are some things which are commonly used. And as I said, we cannot capture this epsilon part. So that becomes the error. And we will later study these things when we have machine multiple linear regression. So that's it for this one. And we will continue with the PYQs in the next video.